Today, we're very proud to present Selecting Arc-Rated Flame-Resistant Foul Weather Gear. This Safeopedia webinar is being presented by National Safety Apparel, a preferred manufacturer member of Safety Network. Safety Network demands excellence, so demand Safety Network. It is now my great pleasure to introduce to you today's presenter, Dion Murray. Dion brings more than 30 years of experience in safety product knowledge and training. Starting in the family business, Safety and Supply Company in the 80s, Dion developed her passion for product knowledge and training. She served the industry on the Washington State Construction Safety Council, ASSE, and Labor and Industries Training Resources. She has assisted users and conducted training programs in proper selection and application of fall protection, gas detection, arc-rated flame-resistant clothing, high-vis safety apparel, and other critical PPE. She joined National Safety Apparel in 2013, bringing her passion and knowledge for high-vis and FR fabrics to a product manager position. Today, as a business development manager at National Safety Apparel, Dion provides field sales support and product training. She collaborates with their product development team, bringing field knowledge of the customer experience to help provide solutions to the ever-changing needs in flame resistance, high visibility, and rainwear. Dion is currently serving on the ISEA High Visibility Products Group of the ANSI 107 Committee. Dion lives in Washington State along with her 4 siblings and 3 grown children. Dion says, family is at the heart of working in this industry. I want everyone to come home to their family safely. Awesome. I'm very grateful to now have you sit back, relax, and enjoy this presentation. With that, Dion, please take it away.
Thanks, Jamie. Okay, as we prepare to discuss the options for protecting from the elements, here is a question to ponder. What job works in an environment where they need protection from temperatures that can be 3 times as hot as the surface of the sun and sub-zero in the same day? Astronaut? If that was your guess, that's a pretty good guess, and beyond the scope of our work today. In industrial applications for arc flash and flash fire, it's the electrical worker. An arc flash can be up to 3 times hotter than the surface of the sun at the source, and it can happen in an outdoor environment with storm conditions, rainy, windy, snowy, sub-zero temperatures. As Jamie said, I'm Dion, and I've spent the last few years working on the development of arc flash and flash fire outerwear at National Safety Apparel. And today I'll share with you some of the key things I learned about the hazards, the choices, and how we can simplify the process. One of the things that I learned is that as more solutions and features become available for flame-resistant foul weather gear, selecting a garment can be more complicated. And so to simplify the process today, we'll look at applications, hazards, and fabric technologies to discover how we can make the best recommendation or selection. Today, we will focus on hazards that are commonly found in these industries, where workers may be exposed to extreme weather as well as flame hazards. So the oil and gas industry, pulp and paper, other combustible dust, as well as the electrical power, utilities, distribution, and construction. All of these industries commonly have applications that fall into either the arc flash or flash fire hazard category. So why foul weather gear? Innovative fabric technologies that are causing us to create a new category, foul weather gear. Because people who work outdoors face all types of challenging weather, kind of like what you see on screen there, and in some parts of the country, I think at certain times of the year, you could have all of those on the same day. Rain gear is something that you would put on only when it's raining, and you would take it off as soon as possible, usually because it's hot and uncomfortable. Foul weather gear is something that is comfortable to wear for extended periods of time in all weather conditions. With new flame-resistant fabric technologies that are available today, workers can achieve protection from chilly, extreme cold, wind, rain, snow, all of this in the same garment. They no longer have to be a separate garment. So what do workers want? The answer that I get to this question most often is related to comfort. I want to be able to do my job and have the PPE I wear be comfortable and not interfere. So comfort is definitely a driving trend in the flame-resistant clothing category. And there are several benefits to providing that. Improve safety and productivity. So workers who are not distracted by the physical discomfort are more able to focus on getting work done and following safe practices. When you look at worker acceptance and retention, we're certainly at an all-time low for unemployment. So attracting and retaining quality workers is very important to a lot of companies. And then looking at multiple years of wear versus disposable. So not only if you can wear a garment over multiple years, not only does that calculate out to a savings over time, but it can also be a green choice, making a smaller carbon footprint with less waste. And that's something that we're seeing more and more companies wanting to focus on. So looking a little further at protection from foul weather, in springtime, you can have really unpredictable extremes, and winter storm conditions also can offer some very dramatic changes. The guidelines from OSHA for cold stress can be very helpful for this. OSHA also has some guidelines for heat stress that you might want to check out as well. But for today, I'll focus on the cold side. So a good system that will help keep workers comfortable and protected has some common things. Light, loose layers, and then the best place to start there is with a base layer that pulls moisture away from the surface of your skin and pushes it out to the outside of the garment so that it can dry, because you want to get that moisture out of the system. And then an outer layer that's highly breathable so the moisture can evaporate out of your system, and an outer layer that has it's windproof and waterproof so you can maintain your body temperature. Because when it's too hot or too cold, the body's main focus is to maintain core body temperature, and that's where the majority of your energy is spent. So workers who are exposed to weather elements without the proper protection are likely going to exhibit decreased performance and productivity. So all of that part of the system to stay dry, and specifically mentioned is cotton. Not to use cotton by itself, because cotton retains moisture and it loses its insulation value. So hydrophilic fibers like cotton should not be used alone. And we'll talk more about that on this next slide. So what are hydrophilic fibers? You may be asking yourself. Hydrophilic fibers are water-loving fibers. They pull moisture in. And so when these fibers load with moisture, they swell, and then they interfere with the breathability of fabric. Hydrophobic fibers, on the other hand, are water-hating. They push the moisture away, they push it out. So pushing water out and not absorbing it, that is what makes fabrics made with hydrophobic fibers dry faster, because they just don't take that water in. So now that we've looked at some of those comfort features and the hazards from foul weather, what are some of the other hazards that we will explore today? We're going to take a look at arc flash, flash fire, visibility, chemical splash, hot liquid and steam, and anti-static protection options. So starting first with a flash fire hazard, waterproof garments like rainwear and foul weather gear fall under a different standard than the arc flash clothing garments that are covered by ASTM F1506. F1506 doesn't address coated or laminated fabrics commonly used for rainwear applications, so users are directed to ASTM F1891. And so similar to F1506, the similar FR requirements to F1506 with the addition of specifications for leak testing, waterproof fabrics and seams. ASTM F1891 also specifies the D6413 vertical flame test and F1959 mannequin test, which are the same things in F1506. And this evaluates the fabric and assigns an ATPV, which is the arc thermal protective value. You might also be familiar with that as a CAL rating. So this hazard that we're looking at here is primarily going to apply to applications in the electrical utility, power distribution, electrical contractors. It could also fall into many manufacturing applications where maintenance personnel might work on electrical equipment. So then looking at the next hazard here, flash fire. Flash fire testing for waterproof foul weather gear and rain gear is specified by ASTM F2733. Similar to NFPA 2112, it requires, again, that same D6413 vertical flame test and a mannequin test, ASTM F1930, in a generic coverall form. And this qualifies the material to be used. And parts of that are very similar to NFPA 2112, which also has the vertical flame and the generic mannequin test. But 2733 additionally requires the garments or the fabric, to meet a lower predicted body burn percentage of 40%. Instead of the 50% predicted body burn that's allowed in NFPA 2112. ASTM 2733 also requires an as-sold garment test, so that F1930 mannequin test, a second one is required for waterproof garments to test the as-sold garment. So remember we talked about there was a generic coverall test, and then there's a second test for the as-sold garment. And this category primarily applies to applications in the oil and gas industry, upstream like drilling and fracking, downstream like refining or gas utility, midstream transportation or pipeline. It can also apply to pulp and paper, other combustible dust applications, as well as some chemical applications. Here is another category of hazard that might be related to a flash fire hazard. Some flash fire hazards also have the concern of static discharge. So anti-stat fabrics that meet one of the test methods that I'm showing you here would provide some protection also from garments creating static that could discharge and ignite gas vapors or combustible dust present in the air. The gas probe Shirley method is kind of my favorite because I like that it's trying to create a worst case scenario of conditions. It's trying to really simulate a live potential, because they take the fabric and they vigorously charge it with static, and then they put it in a hydrogen gas environment to see if the static built up on that fabric will actually make a jump and ignite the hydrogen gas in the chamber. So that one's my favorite personally, but there's also EN 1149. This is the European standard, and this is also commonly used to measure static dissipation of fabrics. Okay, visibility hazards. Many utility, construction, and active work zone, include a hazard for workers being more visible to moving equipment and drivers of vehicles. In the U.S., this would be the ANSI ISEA 107 standard, and in Canada, it's the CSA Z96 standard. Both standards specify 3 levels of protection, and those are related to the level of the hazard. So class 1 being the lowest hazard level, and class 3 being the highest. Work zone fatalities are rising, so this is a really important part of your hazard assessment. And the statistics that you're seeing here on screen will be available at the end of the presentation today also, so you don't have to necessarily write that down. But these work zone fatalities, this data was put together by the Federal Highway Administration, and it's based on Bureau of Labor Statistics data, and if you are familiar with that data, you know that we're usually about 2 years behind So in 2019, we see the evaluations of 2017 data. So this is our most current information. The ANSI standard, the visibility standard, actually also specifies that if you are needing visibility and flame-resistant rainwear, that you would meet one of the standards that we looked at previously, F1891 or ASTM F2733. Okay, let's take a little closer look at chemical hazards. This is an area where we're getting more questions, and it appears to be an increasing issue for flame-resistant workplaces. So in order to understand the different levels of protection that are required here, I'm going to share a little bit about a couple of different standards. This is standard relating to liquid chemical penetration. And if you're a user of garments, I think it's important to understand what level of protection is required for you and your application. So do you need to meet a standard, and what chemicals are you exposed to? And if you're a recommender, I think it's really important to understand the differences between the different types of protection and the different standards that are out there. I've seen a lot of different information out on the web when people are trying to select garments. There's some very generic information that lists just the compound like PVC or neoprene or polyurethane, and then it will list the chemicals and give you sort of a go, no go with that chemical, like bad, good, fair, excellent. So it kind of gives you an idea how those compounds generally will react to certain chemicals, but it's not fabric specific related. So here I'm showing you two standards that are very specific to a fabric and a garment. So ASTM F903 for liquid chemical penetration is a fabric level test, and NFPA 1992 for liquid chemical splash is a garment level test. So this is a higher level of protection than anything that's talking about 903 can offer you. In fact, the fabric level test, ASTM F903, is required for the 1992 qualification. And in NFPA 1992, it's a certification process. So much like NFPA 2112 for flash fire, it's a third-party certification of a body like UL. So ASTM F903 is actually measuring the liquid chemical passing through the fabric. So liquid chemicals, or the chemicals, are put on the fabric. They're observing what the fabric does when exposed to that chemical, and then measuring the time that it takes for that liquid to pass through the fabric. So again, it's all about liquid chemicals, and this is just giving you an idea how that fabric specifically is going to react. And then NFPA 1992 is going to give you a higher level of protection. So if you're expecting to have chemical splash happen on a regular basis in your workplace, this is going to happen on a daily basis, you're going to want to go to this higher level of protection, commonly referred to as level B or C garments. But if you're not expecting chemical splash to happen, but chemicals are present, and just in case there were an incident, you want to know how the fabric would react, ASTM F903 might be good for you. So that's enough for today on chemicals, so we could probably talk all day about that. So moving on to hot liquid and steam. Hot liquid and steam hazards are an emerging concern also in flash fire applications like pulp and paper or oil and gas, where there are hot liquids under pressure, which could present a burn hazard from steam or hot liquid. And because there's no U.S. standard requirement currently, this can be difficult for companies to evaluate, how do I find something that provides protection? So I am using the Canadian Flash Fire Standard CGSB 155.20 as an optional test specification here for hot liquids and steam, because they do have a portion, it's an optional portion of that standard, where you can evaluate garments and fabrics for their protection from hot liquids and steam. All liquid-proof garments are going to give you some level of protection from liquids or steam getting through a fabric, but the evaluation here, more importantly, is on the thermal heat transfer and predicted body burn. And that's what we're trying to protect people from, is the burn hazard that hot liquid and steam present. So in the CGSB standard, there's a mannequin test, similar to the flash fire or arc flash mannequin test, where there are temperature sensors all over the body of the mannequin, and it's exposed to hot water and hot steam, and then there's a measurement of temperature transfer to the inside of the garment to predict body burn. So the Gore-Tex Pyrad fabric actually passes that optional mannequin portion of this test. I looked and I have not seen anyone else advertising to this spec or any measurable spec for hot liquid and steam. But I wanted to offer something here because I see this as a really emerging hazard. So now that we have looked at applications and hazards, let's explore the fabric choices. So in the 80s, we had treated polyester. It would self-extinguish and it was inexpensive, and that was the best that we had at that time. Unfortunately, we still have these products in the market marked as flame resistant or self-extinguishing, even though safer solutions are available, and likely because they're cheaper. So I want to show you something. This video gives you an example of rainwear that is marked as flame resistant. However, it does not meet the arc or flash fire standard. So there's the 3 seconds of flame from the flash fire test. And you can see from this video why it's important to have a true flame resistant outer layer, as the garment would melt and drip and stick to your skin. It's still burning. This is definitely going to add to the extent of the injury and not going to be the optimal option. So going back to our evolution of fabrics, I'm going to ask you whether you are a recommender or someone that is using these products, that you just eliminate the treated polyester, treated nylon option of self-extinguishing from the selection process. And then moving on from there in the evolution, in the 90s, we had polyurethane and neoprene and other laminates on FR fabrics that actually passed the arc and flash fire testing, but they offered no breathability. However, at that time, that was the best that we had. In the 2000s, we got breathable, arc rated and flash fire rated fabrics. We took high-vis shirting fabric that was treated with a water repellent and then laminated to a waterproof membrane. And then on the inside, there was usually a lightweight FR knit fabric to create a tri-laminate, waterproof, breathable fabric. And that was the best that we had. The problem with this type of technology goes back to the fiber story we discussed in the beginning. So what happens to the water in these situations? So remember those hydrophilic water-loving fibers that pull moisture in? This is the problem with this old-style breathable waterproof technology, that the fabric performance is limited because we have to use shirting fabrics that have those hydrophilic fibers in them, instead of being able to use true waterproof rainwear fabrics made of 100% hydrophobic fibers. And the result was that the water repellent finish that I talked about being on the outside, it eventually, in storm conditions where you're in a rainstorm or in any type of sideways moving moisture, maybe it could even be snow, but that water repellent finish, it eventually breaks down. And then those fibers do what they're made to do. They absorb water. And then the garment, remember we talked about how those fibers swell, so they get filled with water, they swell up, and then they plug the little tiny microporous openings that are designed to let moisture vapor escape from the garment. So then moisture is trapped inside. And it feels cold and clammy inside the garment because the water vapor is not getting out, and then you have a whole layer of cold water on the outside surface of your garment. Which brings me to the happy part of my story. In this evolution of fabrics for arc flash and flash fire resistant rainwear to foul weather gear, there was really a cool discovery that hit the market around 2015. The makers of Gore-Tex had a breakthrough with Pyrad technology. Gore being the leaders in waterproof and highly breathable technology, they took the best hydrophobic water-hating fiber, if you remember from our little chart, that was polyester, and they made it into a no melt, no drip, 31 calorie flash fire rated waterproof shell. It's truly an amazing fabric. It's lightweight, highly breathable, and shake dry, and it's so different from what we had before. And here's a little chart to show you a comparison of the water pickup difference between Pyrad and a couple of examples of old breathable technology. Gore actually previously made the old breathable technology. They had a monocrylic blend face textile and they had an aramid blend face textile. And this chart here shows you how much more water will be picked up by this old style technology. So under the same conditions, you know, the same size piece of fabric and the same water pressure for the same amount of time, picked up almost 3 times as much for this one here on the far left. So definitely providing us a next generation in fabric technology and water pickup in wet conditions. But going beyond that, also the technology has superior flame resistance. And the magic is in those tiny little dots that you can see on this close-up image of the fabric. And those dots that you see, those are actually the Pyrad technology that's sandwiched in between the face textile and the waterproof membrane in the back. And what they allow that fabric to do is to utilize a 100% hydrophobic fiber. So that's going to give you the best performance in wet conditions. And it makes that fabric, no melt, no drip, 31 calories in the electrical utility fabric and flash fire rated in the combustible dust or oil and gas fabric. No other FR fabric available offers this same value story of waterproof, breathable, incredible comfort with amazing protection. And so because we like watching videos here, I want to also show you a video that you can compare with the one we saw earlier of earliest technology with the latest technology. So here's a flash fire test of the Pyrad fabric in a finished garment, Hydrolite. So you see the 3 seconds of flame. Notice no after flame. You see no melting, no dripping, no burning. Really an amazing story for protection. Once you have identified the hazards and the specifications needed, then you have a good understanding of the fabric choices that we talked about. Now you're ready for the selection process. So we have created a price to value continuum where you can find products across the continuum that offer protection. So you can find flash fire and arc rated products across this continuum, but you do have a lot of choices. So let's explore some of those. First, we will start on one end. When you look at price, when you make the choice based on price alone, you have the lowest upfront cost. However, you could have some hidden costs. Some of those hidden costs that we touched on earlier could be lost productivity due to worker discomfort, could be related to safety because of worker distraction. You also have a disposable mentality. So even though the upfront cost is lower, you're using sometimes multiple garments per year, and over years of wear, that cost can add up. So then when you go to the other end of this continuum on the value end, you have innovative fabrics that have a higher upfront cost with some value adders. So you may see immediately increased productivity. You may experience increased safety due to the lack of that distraction that we talked about, or just from employee satisfaction. They are comfortable wearing the garment, so they're more likely to wear it. And you also might have more employee retention because they feel more valued, that the company's investing in them. A better product says, we care about you, we care about your safety, we care about your comfort. And you can also create a system that can replace other garments with one solution. We'll talk about that more as we get in depth. So let's take a look more specifically at the price side of the continuum in options, advantages, and disadvantages. So some of the fabric options in this price point option: PVC on non-woven aramid or PVC on Nomex. This is the lowest cost option in this section. Neoprene on Nomex, which tends to be a stiff fabric. However, it wears like iron, so it's very durable. The neoprene on Nomex option, though, should be noted, does not meet the ANSI standard for fluorescence. So it has some benefits, but not all there. Polyurethane on FR cotton, I think, would be considered the top option in terms of protection here. It tends to have a softer hand and be a more flexible fabric while you're wearing it. However, disadvantage-wise, all of these laminates do not offer breathability. A lot of them are stiff, or they're heavier and more bulky than other choices. And they have lower flame protection levels than the options at the high end of the value continuum. And then also, as we talked about earlier, treated more like a throwaway item, so you have a larger carbon footprint. But even among these low cost options, not all fabrics offer the same protection. So let's take a look at another video. Videos are my favorite. They just tell so many stories. So here is a flash fire test of 3 popular fabric choices. It demonstrates some of the differences. Featured on the far left, polyurethane on FR cotton. The middle is a composite film on Nomex, and on the right is a PVC on Nomex. So as you can see, there's quite a bit of difference. They were all exposed at the same time. We lined up these videos so that they would all start at the same time, and you could see the results immediately. And you can see that on the far right, this product is continuing to burn and continuing to burn. So we're going to go ahead and look at the results while that continues to burn. And so as I said, in this category, not everything is created equal. You can see from these after flame and predicted body burn results here that you can have a big difference even on the low end of the price continuum. So polyurethane on FR cotton, which is listed on the top there, that tends to be the higher price product. And then PVC on Nomex tends to be the lower price product. And even within the PVC on Nomex fabric, there are many different fabrics and that will get different results. However, it's just important. The results are very important, so always check this. So moving on from the price point products in non-breathable laminates, we move into premium fabrics that have more features. And breathability is certainly a huge benefit stepping up in a premium fabric. And we talked about the different fabric technologies, and certainly the old style breathable fabric technology is still on the market. And actually, until a couple of years ago, NSA still had these fabric in garments as well. But what we found was that it was kind of a disservice to our customers to continue to offer them because price-wise, they were similar enough to the PIRAD technology, and the PIRAD technology offered so much more protection and performance that we just didn't want to settle there. So we've moved up, and we have this one fabric right now in our market that is currently covers this category of being highly breathable, shake dry technology, all hydrophobic on the face textile, and that's the Gore-Tex Pyrad fabric. And I really think this fabric is changing the definition of gear because it can handle all foul weather types and it's comfortable to wear all day. And this gives workers the option to have a true foul weather gear system. If you remember from when we talked about the OSHA guidelines for light, loose layers, then in a system you would start with a moisture wicking base layer. If it's cold, you could add an insulative layer, and then you have an outer shell that's waterproof, windproof, and releases moisture. So you can do all that without the bulk of some of the other solutions that are out there. Pyrad's going to have a higher upfront cost than traditional heavy jackets or non-breathable rainwear solutions. However, like we showed on our continuum, it does deliver a better value. You can find an immediate productivity pickup. You can find benefit from increased safety, which can obviously lower a company's overall cost. And you're going to immediately see a huge pickup in worker comfort and worker satisfaction. And then for someone who wears these garments a lot, over time, you're going to see these garments last for multiple years. And because they can be easily laundered at home and they can be repaired out of season, it's easy to keep them working throughout many seasons. So earlier we talked about ASTM F2733 mannequin testing and the requirement to be lower than a 40% predicted body burn. And this slide from Gore, and I'm sorry if it's hard to read the fine print here, I pulled it from the website, but this shows a good comparison also of products on the low end of the price scale versus products on the high end of the value scale. So this is the result of a flash fire test. So where you see purple is where it's predicted to be a third-degree burn, and where you see red is where it's predicted to be a second-degree burn. And the reason why all the heads are purple is because that's always predicted to be a third-degree burn area, and it always calculates at 6.57% for the head. So the head is kind of always on its own. So when you look at the comparison of these results, the PVC garment on the left tested with 32.79% predicted body burn, and you add the head to that at 6.57, you get to 39.36. So just barely making the under 40 requirement. And then you compare it to the high value product on the right-hand side, the Gore-Tex Pyrad fabric in a finished garment. That tested at 3.3% predicted body burn, add the head in at 6.57, and you have 9.87%. So looking at these 39% compared to 9% predicted body burn, these test results matter. So definitely want to check that, and that's a huge part of the value story. So finishing up on our comfort and value section, the Gore-Tex Pyrad, again, being the only fabric that I see as hitting all cylinders on the value end of this spectrum because it's lightweight and it's shake dry. You can wear it all day and be comfortable. It's only 100% hydrophobic base textile. And then you have the optional protection from many different hazards, whether that's flash fire or arc flash. You can get anti-stat protection. You can have fabrics that are resistant to petroleum and oil-based muds or other chemicals. And you can have hot liquid and steam protection. This really does sum up a great value story. So finally, on that, I just want to wrap back to comfort. What do workers want? I just think this is such an important part of the selection process because studies show that workers are more likely to wear their PPE if it fits well and it's comfortable. So obviously, when workers are wearing their PPE, they're more protected and we have higher levels of safety. But also in an incident, that can be a huge difference in terms of a cost to a company or a family for the damage that it does to that person's life or health. So providing comfort in your selection can be a huge improvement to safety, productivity, and worker acceptance. And these benefits can also change the culture from a disposable rainwear concept to an important tool for all foul weather. And when I talk to different committees from companies who are looking at making a big change in gear, a lot of times those companies are in a disposable, non-breathable rainwear product like we looked at. And they ask, well, how do you go from, well, basically our workers take this, they wear it in a storm, it gets dirty, it gets wet, it's wadded up, it's in the back of their truck, and they don't think about it again until the next time that it's raining, and then they need something, and okay, well now it's, it's ruined and it stinks and it's dirty. They throw it away and just go to the tool room and get another set. Well, aren't they going to do that now? We've spent all this money and they're going to do the same thing with this expensive gear. What we find is actually the opposite of that. And I think it's kind of a human nature thing. When you really value a tool, when it really is comfortable and it does something for you, it really makes a big difference in terms of how they're going to treat that garment. So if they like it and it's working for them, they're going to take care of it in a different way. They're probably going to wear it a lot more often because, as we talked about in the beginning, rainwear is something that you only put on when you have to, and you take it off as soon as possible because it's uncomfortable. But having one of these highly breathable, higher priced garments, people are going to wear it more often. They're going to take care of it. They're able to wash it. It's just a different situation, and we do find that result over and over again. Okay, so just to summarize, let's wrap it up. What we looked at today was applications and hazards. We explored those. Then we spent a lot of time looking at worker comfort and how those aspects might affect overall safety, productivity, and the value of a solution. We looked at the different fabric technologies and that evolution over time to foul weather gear. And then in the selection process, we looked at the options that we have from the price side of the continuum to the value side of the continuum. So I hope that you found this process and information sharing valuable to you and actually simplifying the process. As I mentioned, we do have these additional resources, a few things that were referenced in the presentation, and you don't have to write all of these down because I believe that Jamie from Safeopedia will be sending out a copy of this presentation for you, but I wanted you to know that they were there. So I thank you for being here, and again, I hope you enjoyed it, and if you have any questions, we would love to take them.
Right on. Thank you, Dion. Yes, a few questions. And actually, I think you just covered Justin's first question here, but thank you, Dion. What a great presentation. Yeah, and comfort, what a big deal. It's often overlooked, but it is human nature. We take care of those things that we value, and yeah, what a great presentation. Thank you. So we'll get right into the questions. Quick reminder, everybody, get your questions into the GoToWebinar console. If we happen to run out of time, we want to be absolutely respectful of your time. What we'll do is we'll follow up with you after the webinar, if that's okay, and we'd love to still answer your questions. So get them in, and we'll take them on a first-come, first-served basis. So Justin's first question, I think you've answered it already. It says, you covered a lot of different testing methods. Is there a place or a set of documents that has this information?
Yeah, good question. So I did cover a lot of testing methods. The first thing that you should look at when, if you're recommending or selecting is understanding what specifications are required for the job that's done. So a lot of different industries are covered by requirements, like NFPA 70E, for example, has a lot of specifications in it about what employees must wear to be protected. So that is the best first place to start. If you want to know about the specific garments that you're selecting, the manufacturer of the garment should be able to provide you with a very clear list of the standards that that garment meets. And if needed, like in our particular case at NSA, we have a YouTube channel where we post a lot of flash fire test videos. We post arc flash test videos, so people can see those things. I don't know about you, but you can obviously tell by me that I really like the videos. I think that that's very powerful to look at that information. And I know a lot of other manufacturers do that as well. So you can get that information from the manufacturer. Hopefully that answered your question.
Awesome, thanks, Dion. And those links you shared, again, we'll be sending out a link to the recording of the presentation along with the slides. So great information in there. And yes, video, more than 1,000 words for sure.
I love that.
All right. Yeah, me too. Simon has a question here. How do you justify the cost of going from a low-cost option that's non-breathable to something more expensive and higher end, like the Gore-Tex you mentioned?
Okay, well that's a good question, and it's one that we get a lot. And there are a lot of answers to that. However, I will say a very, very good place to start, whether you're recommending this product or in your company, or if you're a distributor consultant that's recommending it to your customer, a really good place to start is looking at how many of the disposable or non-breathable garments are consumed per year at the company. I've found a lot of times that when companies go back and look at this, because normally those type of garments are handed out from the warehouse, so you can find out how many garments per year are going out, and sometimes it's more than one set per employee. And then if you take a look at that and compare it with how many years of life the breathable garment that you're recommending is anticipated to have, you can start to make a value calculation based on that. A second place to look that I think is a good idea is to have the company themselves, whether, so if you're from the company, great. If you're recommending, definitely have the company themselves go and ask the workers how they like the solution that's currently being provided and any issues that they have with it. So those are two really good places to start out with understanding if this is a good recommendation and a cost justification for the company that you're working with.
Great, thanks, Dion. All right, yep. Prince has a question here. What about the face when a flash hits? Does this suit or these suits come with shield, or should we use some other face shield to protect? Great question.
That's a great question. And depending on the industry that you're in, so in the arc flash industry, depending on the level of hazard, there is a recommendation. So I'll give an example. For instance, the Gore-Tex material that I mentioned in there, in the arc flash category, the product that's made for the utility market, it's a 31 calorie fabric. So that's a significantly high number. And actually, to protect at that level, there are a lot of companies that are doing a 20 cal suit or a 20 cal coverall, not waterproof, a 20 cal coverall or 25 cal coverall, and then they're combining the face protection that's required for arc flash with that. So yes, a face shield and head protection based on the hazard that's required. That might be a balaclava, that might be an actual hood. So in that particular case, if you were exposed to that level of hazard, you could combine the face protection with your actual foul weather gear versus having to go to a coverall for that type of hazard. So answering the question again more specifically for Prince, the face protection should match what the requirements are by the industry standard. So either arc flash or flash fire, what the hazard is will determine what face protection is required.
Great, thanks, Dion. All right, Ryan has a question here. Can you wear these types of solutions over non-FR garments and still maintain protection? Great question.
Oh my gosh. Okay, so this is a question that we get a lot, and the answer based on compliance can vary. However, the recommendation I give all the time is always to have a 100% FR system. And the reason that I say that, well, partly goes back to, remember all the videos that we looked at? I mean, you can have a garment with a 43-second after flame that meets the standard. So if you have a 43-second after flame and you are not wearing an FR garment underneath that, and remember the video with the 43-second after flame, many of you can appreciate the location of that afterburn, you would want some protection. So I never recommend that you don't have a FR system. You know, there are another issue, you know, Hugh Hoagland will share with you, if you are in the arc flash area, you probably know who Hugh is. He's the guru. And Hugh will share with you that there have been incidents of non-FR jeans where someone had a FR coverall on the outside. There was an arc incident, and the flame actually went up the cuff of the coverall and ignited the jeans underneath. So for those reasons, I always recommend, the best recommendation is always 100% FR system.
Great, thank you, Dion. All right, a very similar question is Carrie is asking, can you talk a little bit about the layering of FR and waterproof clothing for when it's cold, so working in a cold environment?
Sure. Yeah, I'm happy to touch on that because I think that's really important. One of the benefits that I did not mention with the Gore-Tex Pyrad fabric is that it's resistant to cold cracking. So when we're talking about extreme cold, not all foul weather gear can really handle those sub-zero temperatures. It starts to get stiff and brittle and can actually crack. So the Pyrad fabric is resistant to cold cracking. So when you have a system in extreme cold, you want to start out at the base layer. You want a base layer that's moisture wicking, because most of the people who are doing the work in these fields will have times of heavy labor, and then their body's going to generate energy and heat and moisture. And you want to move that moisture away from the surface of the skin, because that's what keeps that person from getting too cold. That moisture is dangerous. So remember in the OSHA guidelines, it said stay dry. So moisture can come either from the outside of your system, or it can come from you generating it. You need to move that through a base layer that's moisture wicking. And then the next layer will be an insulative layer that's relative to the temperature that you're working in, along with the amount of labor that your body is doing. So the amount of heat energy you create can also have an impact on how much insulation you need. So you're going to have an insulative layer. And then the outer layer needs to be windproof and waterproof and breathable. This is especially important in cold environments. So any moisture you're generating can move out of the system for your protection, but no wind and no water can come into the system because you have a good outer protection. And I'll give an example of that. I've seen a 7-ounce fabric, the Gore-Tex fabric, 7 ounces over a sweatshirt and jeans in a Wyoming winter. So you know it's super windy, cold, dry. Somebody was comfortable working in that all day. They didn't need a lot of insulation. So you can have a lot of variables there from the person's own amount of labor and the different layers, but light, loose layers, that's the recommendation. It traps those layers of air in there, and that's what keeps you warm.
Great, thank you, Dion. All right, Prince has a question here. You were telling us it is a multiple wear, not disposable. So the reuse of garments. Prince is asking, what is the maintenance requirement of the garments? So how do you maintain these garments going forward? Maybe talk about cleaning, laundry, if that's applicable.
Sure. Well, I will say one of the great things that I love about the Gore-Tex fabric that we didn't have previously in some of the other breathable fabrics at NSA, and is definitely very unique from the laminate non-breathable fabrics, which do not wash well. The Gore-Tex Pyrad fabric likes to be washed and dried in the dryer. So in your, if it's not a contaminated garment in your home laundry, you can wash it on the normal, like permanent press setting, which is a medium temperature. Use a mild detergent. You could put it in your dryer on the medium temperature setting, again, permanent press. It actually refreshes the protection of the fabric. But it also ensures that we talked about water plugging up those tiny little holes. You can also have dirt and oil and debris get caught in your face textile and interfere with the breathability of it. So you want to wash and dry it regularly if it's a breathable garment. So easy wash and dry is great, and I love that about the Gore-Tex fabric.
Awesome technology. That is great.
Yeah, that's amazing.
Okay, Tom has a question. How do these products hold up to blackberry pit pricks?
Such a great question. Yeah, so briars, thorns, blackberries. Tom's probably from my area of the country in Washington State, and blackberries are everywhere. And so for utilities that are brush cutting or, doing a lot of, they do a lot of, in the brush to get to the equipment that they have to work on. And blackberry thorns, other thorns, they are like little needles, and they are going to puncture the fabric. So this fabric is amazing. However, it's not puncture proof. That would be a very difficult suit to wear. You won't get this kind of lightweight, breathable technology and be puncture proof. So I highly recommend that you take precaution to protect it from blackberries. If you wear flame resistant gear in the arc flash zone, that you're doing brush cutting where you're not going to be in the arc zone at all, you might want to consider using a different product that will give you some protection, but it's not, maybe doesn't cost as much as a flame resistant option, or put something over the top of it, like leather chaps or something like that can be added easily to the garment when you're outside of the arc flash zone. So definitely you want to protect it from that. But if it does happen, which it can happen, there's a repair process for that. So there's an in-field repair process that's easy, and a factory repair process, so that those garments can continue to work for you.
Oh, that's interesting. There's a follow-up question here from Prince. Can you talk a little bit about the durability of the product? So you talk about puncture, not resistant to puncture, but maybe describe the durability of the garments.
Right. Well, trying to look across the price to value continuum and give you some examples from my experience. We talked a little bit about the what I call disposable, so the non-breathable garments on the price end of the scale. Those garments don't tend to last a lot of seasons, a lot of times just because how people take care of them. However, other times they can last multiple seasons because the person who owns it so rarely ever wears it. If ever, it's just one of the things that they, carry around with them as an option, but, they just wear their hoodie and get wet anyway. So there can be a lot of variance there, but what I tend to see when people do wear those garments, is that usually within a year's time or less, there's a crotch rip out or a shoulder seam rip out, or the description of, I left it wadded up and dirty and wet in the back of my truck and now it stinks. So I would say those products are a year or less, tend to be a year or less. Then in the middle of it with the old fabric technology, because those products don't tend to, at least this was my experience, don't tend to wash up as well. 1 or 2 years of wear might be experienced. And then on the high end of the value scale with the Gore-Tex Pyrad fabrics, because of the repair options and because of the way that they wash and dry so amazingly, just like a retail product. I mean, most of us have some type of waterproof shell that we have used either for outerwear, as in snow or, that kind of play, or just to be protected from rain. We have some experience with that. It washes up amazing. And because of the repair process available, though we see very few repairs, those garments are lasting 3 to 5 years. So you have a really higher level of longevity of that product.
Great, thanks, Dion. I see we're just a bit over time. I will get a couple more questions in. There's 2 I'm going to combine. So Sarah and Gabe, really appreciate your questions. The questions are, and forgive me, Dion, I'm going to kind of combine these. So the first one goes from Sarah: how do I know what level of protection my fabric or garment is providing? And Gabe sort of touches on the same thing. Is there a standard for labeling for this type of clothing? An example, FR rating.
Okay, so both of those are very well related. For Sarah, I would say to know the protection level of your garment, there should be a label. It's required by all of these standards for the garment to be labeled with the standards that it meets. So you should be able to see that in the label of your garment. Typically with rainwear and outerwear, foul weather gear items, that would be at the neck of the garment or in the side seam inside the garment. So look at those labels and they will tell you the names of the different standards that they meet. If you have some concerns about what any of that means, or if it's not right, you can bring it to the safety professional at your work. You can bring it to the consulting distributor or the manufacturer to have that explained. And then as for the standards for labeling, I think I kind of wrapped in that answer. Yes, there are standards for labeling. Yes, it does have to be labeled. And the standards that I went over today, those would all need to be on your label.
Awesome. That's great to know. Thank you, Dion. All right, we are at the end of the presentation. Definitely thank you, everybody, for the great questions. Before we sign off, Dion, any final words?
I just really want to thank you for putting this together, Jamie. I really appreciate Safeopedia and Safety Networks for giving us the opportunity to bring this content to the group.
No, thank you. It's really our pleasure. You did most of the heavy lifting, so we really appreciate you and National Safety Apparel, and we know Heidi, you're out there somewhere behind the scenes, also making it all happen. So special shout out to Heidi. But really huge thank you to the audience. Without you guys,
sure.
Huge turnout today. Really want to thank you. We know you have, time is precious. We know you have a choice of where to spend it, and we're really grateful that you spent some of it with us today. So with that, we want to thank everyone again. Take care and stay safe and have a great Easter weekend. Take care, everybody.
Thank you.